Gravitation, this is a study of forces between all the astronomical bodies or heavenly bodies. Though this part is a very small part which belongs from astronomical science. So astronomy is very wide subject of study, right? In this chapter, which is in our syllabus, gravitation, this word actually means this is a force by which each object in this universe attracts the other one. For example, the force between sun and moon, force between earth and moon, force between me and the camera, everything, force between any two bodies in this whole universe is described under gravitation. The word gravity is also the force when one of the bodies which were used in gravitation is earth. For example, force between a planet and sun is called gravitation. Force between this marker and moon is also gravitational force, but force between earth and this marker is now will be calculated under gravity. So gravity is another word for force of gravitation when one of the two bodies is earth, right? Now during the evolution of science or the whole period when this subject evolved, there were a lot of people involved in the study of the whole astronomical science or the topic gravitation. So we'll briefly discuss how things happen and how things evolved in case of gravitation. First of all, Galileo was a scientist. He studied that irrespective of mass, all the bodies are actually pulled towards the earth. Doesn't matter what is the height, what is the size, what is the mass, if a body is kept freely, it will ultimately be attracted towards the earth and the body will fall with a constant value of acceleration. So Galileo performed a lot of experiments and showed that there is a particular value which is called acceleration due to gravity by which earth attracts different bodies. So Galileo, by his all observations and calculations, by performing various types of experiments, he deduced the value of acceleration due to gravity, though this was incorrect because we are talking about long time back, right? So that time we never used to have those specific instruments or precise calculations or devices, right? So in due to lack of those particular instruments, he didn't get the exact value, but his value of G was very close to what we use today, the accurate value, alright. So during the time of Galileo, there was another noble person, Tycho Brahe. He belonged to Denmark. This person spent almost his entire life studying the motion and position of all the astronomical bodies. For example, he kept on watching stars and various planets. How do you differ star from a planet? Though this is out of the topic question, but planets, they don't flicker in light, but stars do, right? Because planets are comparatively less distance from the earth or they are very close to earth. Now Tycho Brahe, he spent almost his entire life in studying the position of planets around the earth and he put this all into data. What happened? Kepler was another scientist who studied all this data which was done by Tycho Brahe and he put that data into three definite set of laws which explained the planetary motion of any object or planetary motion of any planet, to be very precise. So Kepler was the person who gave Kepler's laws of planetary motion. These are the laws which we still study. This is also topic in your syllabus, which gives us the exact position of a planet in terms of radius, like radius of its motion or time period of revolution, etc. Now Newton studied these laws and on the basis of laws, Newton gave another big theory which is called universal law of gravitation or Newton's law of gravitation, which is the main aspect of our study today or this chapter. So see, these are all interlinked. Galileo said that there is a particular set of acceleration, a particular value with which earth attracts bodies. Tycho Brahe noted the data in which planets move. Kepler noted those data and made Kepler's law of planetary motion, and Newton's on the basis of these laws made gravitational law of gravitation, right? There is another aspect of theory of planetary motion. See, since the ancient time, almost all over the world, many people were involved in studying the positions or the motion of planetary or heavenly objects. Because see, right now if you go during the night time, if you go at your terrace and you'll try to see or watch stars, you won't be able to see many stars. Reason being, due to the environmental dust or pollution present right now, we are unaware or we can't see much of the stars right now. Also the main reason is also due to the lot of light, the glimmer present in the city. But if you go to some remote area which is far from the this light positional value of the city, you would be able to see a lot of stars. So consider the fact that 2000 years back, we are talking about a time, because Ptolemy, he was the scientist, Greek scientist, he did his observation 2000 years back. So that time atmosphere was very clear as compared to now. So that time it was very easy to watch the motion or movement of planets by naked eye as well. So all over the world, those people who were involved in the study of planetary motions, they made some deductive theories, they calculated some positional values, and then they derived their own theories, which were also obeyed worldwide, right? So the first scientific evidence, Ptolemy was the person who gave something in theory of planetary motion, though he was wrong, but he gave something. It was called geocentric theory of planetary motion. What is geocentric means? Ptolemy said that Earth is stationary object, while all the other planets as well as sun as well as moon revolve around the Earth. So his theory was called geocentric theory. Okay. So here the theory says that Earth is stationary, it is not moving anywhere, but everything around is revolving around the Earth. This theory was highly appreciated from the side of churches and all, because they always wanted this thing to be primary, because they sort of thought that where we are living, this world is the primary motive and everything around is secondary. Though Aryabhatta was an Indian philosopher as well as scientist, a mathematician as well. We know that Aryabhatta was a great mathematician, so mathematician word should be coming first. He is also the person who derived the value of 0, right? Now, going back to the topic, Aryabhatta, his work was around 500 years more, or 500 years before the work of Copernicus. Aryabhatta said that if we consider that sun is at the center and everything else is revolving around, including the earth, that according to his theory, if earth is supposed to be revolving around sun and other planets are also revolving around the sun, then the theories of solar eclipses and lunar eclipses would be very easy to explain. But according to this theory, it wasn't very easy to explain all those effects. So Aryabhatta gave this, but Copernicus was the scientist who actually formulated the theory, that is heliocentric theory. According to this theory, sun is stationary, whereas other planets and earth are revolving around sun, and this theory was also followed by Galileo and Kepler and Newton, because this was the right theory. Though this person was punished to death, I mean he was given a death sentence because of this theory, but his actual calculations that time were very much right. Okay, so these are some of the milestones which has happened in past, and now we'll start studying this chapter, gravitation.